Hello children, now welcome to our day's class. Today we will proceed some application based on relative velocity. Before this we have discussed about relative velocity in one dimension and two dimensions. There we have concluded the velocity of one body with respect to other is termed as relative velocity. The single difference between the relative velocity in one direction and two direction. In one direction we have moved on linear plane. In two direction we have gone for the plane. So we are restricted to a plane when we are talking about relative velocity on a plane. And in this case we have taken the help of vector analysis. There we have gone for the resultant of vector, that the component of vector gives us the numeric value of relative velocity. Now today we will go for some application based on relative velocity on a plane, and among them the first is the case of rain and umbrella. Rain, umbrella, drop. If rain is falling in vertical downward direction and a person is moving, then in which direction he has to hold his umbrella to protect himself from the rain? At the same time, what is the relative velocity of rain to the person? So, suppose rain is falling in vertically downward direction, and a person is moving from west to east. It's the west to east. So this is the area where the person is facing the rain. So for a minute just you think that man is also in motion and rain is also in motion. At the instant of contact, the man is taken as a rest. When man is taken as a rest, then the velocity of rain is approaching to that person. That's why while rain, when the person are in motion, they feel more pain from the rain with respect to a person who is standing, because the velocity of the person is zero when the person is at rest. But here, as a person is moving west to east, the motion of the rain is affected by the motion of the person. So this is the case when the person is facing the relative velocity due to that rain. So the person has to hold the umbrella in a direction theta to protect himself from the rain. So now we'll go for the component. If this is the velocity of rain Vr and this is the velocity of person, that is man, then the V will give the relative velocity of T. So let's have the component. This is again the Vm, and here we have the Vr, and this is the angle of inclination. So what is the direction? The direction is the ratio of this Vm to Vr. So that will be tan theta. So tan theta is Vm by Vr. This is the direction on which the person has to hold his umbrella to protect himself from the rain. Or theta equal to tan inverse Vm by Vr. Here, rain is falling in vertical direction and the person is moving, so the person has to hold the umbrella like this. So what will write? It's west to vertical. The person has to hold his umbrella west to vertical, because rain is falling in vertically downward direction. So what is the magnitude of the relative velocity of rain with respect to person? That will be given by this diagonal of that parabol. So V will be the square of V square m plus V square r. V square m is the velocity of the person, Vm is the velocity of the person, and Vr is the velocity of the rain. So by this we will get the magnitude of the velocity, and by this we will get the angle on which the umbrella will be hold. So please pause the video and write down the things. Now move to the second case. Second case is the case of boat and river. Let somebody is sailing his boat in a river where the motion of river is also taken into consideration. That means the river is also flowing. So our second case is Second case is river and boat problem. Rivers and boat problem. In case of river and boat problem, two cases arise. One case when the boat is sailing to the shortest route, and second when the boat is sailing for shortest time. So first of all, we are going for shortest route. Shortest route. So the river is flowing. This is the river. This is the width of the river. Suppose it's a S. It is the width of the river. Now this is the river water. It's flowing. River water is flowing. The time the boat is coming in contact with the water, the boat is thrown due to the velocity of river. So in order to cross the river, the boat's velocity must be more than this. Otherwise it will be thrown. So suppose this is the instant. This is the instant where the boat is coming in contact with the river. So in order to have the shortest route, the boat has to go, the relative velocity of boat should be there. So the boat must be inclined to this direction. So here we have the component. Here VB is the velocity of boat. As the river water is also flowing, this is the river, VR river. So boat will be thrown in this direction. So what is the case? This is the angle. This is the angle of movement. So boat must sail with an angle theta with this vertical in order to go for the shortest route. Because the river will push the boat. So here if the boat is coming here, it will push and finally go to the shortest route. So let's the component, it's the VR, it's the VB, and there also it's the VB, the velocity of the boat. So what is the component here? This is P by H. So the direction of sailing, that is sin theta is VR by VB. We are the velocity of river and VB the velocity of the boat. So theta will be sin inverse VR by VB. And what is the time of crossing? That is the relative velocity. So what is the right? Relative velocity. This is it is the hypotenuse square minus perpendicular square, because this is the relative velocity. V is the relative velocity. So V will be square of velocity of boat minus square of velocity of river. So as I calculated earlier also, the velocity of boat must be more than the velocity of river, otherwise river will drown its away. It can't reach to its shortest distance. So the relative velocity is given by the difference of the square of velocity of boat minus velocity of river. At the same time, the direction of sailing will be given by the ratio of VR to the VB. This is the case for shortest route. Now move to the case of shortest time. Here what is time of crossing? If you have to calculate time of crossing, then time is what? It's the distance by velocity. What is the distance? S. So it is S by velocity is what? It is the V square B minus V square R. So please write it down, the things. Just we have gone for the component of vector, and there we have gone for the direction as well as magnitude. Pause the video and write down things. Okay. Now third and last case will go for the shortest time. It is for shortest route and that is for shortest time. So which step change are there? It is shortest time. Now same case, same boat is going, but this time the agenda is to cross the river in shortest time. So when we are going for shortest time, this is the river is flowing. This time, in order to go for shortest time, we have to sail with respect to the speed of river. That means we will go in this direction to go for shortest time, but river will push us on that direction. We will go in this direction, but river will push us on that direction. So this is the velocity of boat. Velocity of boat. But as the river is flowing, so it will throw it on that direction. This is the velocity of river. So finally the person will reach there. This is the relative velocity. Boat want to go this side, but river is flowing, so river will push it on that direction. So what happens? The relative velocity will reach there. So an extra distance s, and this extra distance x also the boat will cover. So the boat has to sail to this direction, but the river is flowing on to this position. So name this O A B C. OB is the position where the boat will reach in order to go for shortest time. So again see the component. VB velocity of the boat, VR velocity of river, V is the relative velocity of this river and boat, and this is the extra distance the boat has to cover. So direction of sailing, this direction of sailing, the theta, again P by B. So direction of sailing is tan theta. It's the velocity of river by velocity of boat. So theta equal to tan inverse VR by VB. Now, what is the relative velocity? The sum of these two. So, relative velocity V is the square of B plus the square of R with 6. The hypotenuse. Hypotenuse square equal to perpendicular square plus base square. You can pause the video and sort out for yourself also. Because direction is what? P by B. P by B. Relative velocity is what? Hypotenuse square. Hypotenuse square equal to perpendicular square plus base square. That is solved. Now, what is the time of crossing? The river has gone for extra distance. This is the extra distance. As boat has crossed some extra distance. What is that? That is this s square plus s square, because this and this are the same. This is the width of river. So when we are ignoring velocity, we are considering the weight. Then s is the width of river. So it is distance is s square plus x square. X square is this distance. When we talk about distance, this is distance. When we talk about component velocity, this is dr. And what is the relative velocity? We got. So time of crossing. Time of crossing again is a t equal to the distance by velocity. Distance by velocity, that we are knowing from the dynamics. Distance equal to speed into time. So time equal to distance by velocity. So time of crossing t will be under root s square plus x square by under root v square b plus b square r. Please write down the things. Things are only based on the resultant factor. We have gone for 3 cases. I'll provide some numerical. You please try to sort it by yourself. Still doubt, then feel free to message me. Till then, thank you.